Today I'm going to discuss Introduction to Programming Concepts. What are the important points we're going to discuss? We have what is a computer, components of a computer, hardware concepts, digital data representations, bits and bytes, digital electronics, software concepts, software basics, and software development life cycle. So first, let us discuss what is a computer. A computer is an electronic device capable of performing complex computations in a short time. If it is fast electronic calculating machine that accepts input information, processes it according to a list of internal stored instructions called a program, and produces the resultant output information. So what is a program? A program is a set of instructions telling a computer what to do or how to behave. Programming is the craft of implementing one or more interrelated abstract algorithms using a particular programming language to produce a concrete computer. Next, we're going to discuss about the components of a computer. Hardware. Hardware consists of devices like the computer itself, the monitor, keyboard, printer, mouse, and speakers. Inside your computer, there are more bits of hardware, including the motherboard, where you would find the main processing chips that make up the central processing unit, or the CPU. The hardware processes the commands it receives from the software and performs tasks or calculation. Another component of a computer is the software. Software is the name given to the programs that you install on the computer to perform certain types of activities. There are operating system software such as the Apple OS for Macintosh, or Windows 98 or Windows XP for a PC. There are also application software like the games we play or the tools we use to compose letters or do math problems. What are the hardware concepts? First is the data representation. Data representation is the conversion of images, letters, and sound to digital electrical signals. Here, a digital electrical signal refers to a combination or sequence of on and off signals. What is digital electronics? It is the technology used in the manipulation of on and off, or the digital electrical signals. Most computers are digital, as opposed to analog devices. A digital device works with discrete signals such as 0 and 1, while an analog device works with continuous data. As an analogy, a traditional light switch has two discrete states, on and off. A dimmer switch, on the other hand, has a rotating dial that controls a continuous range of brightness from none off to full brightness. The first is therefore a digital device, while the latter is an analog device. Digital data representation. How can a computer represent numbers using bits? The 0 and 1 are also known as bits or binary digits. A 5-bit sequence or combination of 0 and 1 could be written as 10011. At face value, this sequence may have no clear significance. Numeric data like your age, salary, and electricity bill are easily understood by humans. But how is it possible for a computer to show a number using only binary digits? The computer uses the binary number system, which uses only two digits, 0 and 1. There are no 2's or 3's. A series of zeros and ones results in a particular number much in the same way as the decimal number system we use. The table shows how binary system works. The decimal system uses 10 symbols or numerals 0 to 9 to represent numbers, while the binary number system uses only two symbols 0 and 1. Given in this example, notice that there are four digits, namely 0, 1, 0, and 1. The positions of the zeros and ones hold significant values. The illustration will show the corresponding position and value in the binary number system. If the box contains 0, the number is turned off. However, if the box contains 1, the value of the box is turned on and will be added to the value of the number. Such a number system where the placement of a symbol or numeral carries weight is called a positional number system. The decimal number system is considered a positional number system. Given in our example, 0, 1, 0, 1, the first to the right box has a 1 number. So it means it is on. So the value for that box will be added to the equivalent value. Next is the box contains 0. So it means it is off. The value for that particular box will be 0. Next is we have another 1, in which is the value for that box is 4. It means that the box is on. So we're going to add the value of that box to the value of the other boxes in which is on. Lastly, the box for number 8 is 0. It means it is off. Adding the box that has on or 1, we have 4 plus 1 is equals to 5. So the conversion of binary to decimal will be 0101 is equals to 5. How then a computer represent words and letters using bits? Bits can also be used to represent character data. It is analogous to Morse code that uses the dots and dashes to represent letters in the alphabet. In this case, computers make use of 0 and 1 as a replacement to dots and dashes. There are different types of codes. First, we have ASCII, or the American Standard Code for Information Interchange. It defines a set of characters that are displayed on screen. Standard ASCII uses only 7 bits for each character, but it has been extended to 8 bits to accommodate more symbols. Next is we have EBCDIC, stands for Extended Binary Coded Decimal Interchange Code, which is an alternative 8-bit code used by older IBM mainframe computers. Next is we have Unicode. Unicode is an 8, 16, or 32-bit character encoding scheme that provides codes for 65,000 characters. This was developed to represent all the writing systems of the world. Lastly, we have the extended ASCII code. Extended ASCII code makes use of series of zeros and ones to represent 256 characters, including letters to uppercase and lowercase, numbers, and symbols. Next is the bits and bytes. What is a bit? Some people interchange the use of bit and bytes. Note that bit is a contraction of binary digit. The abbreviation for bit is lowercase b. A byte is a collection of bits, 8 to be exact, and usually abbreviated as an uppercase b. Usually, the unit bits are used when measuring transmission speeds. An example of a speed transmission measurement is the transmission rate of a modem. Example given, 56 kilobits per second or kilobytes per second. On the other hand, the unit bytes are usually used in measuring capacity. For instance, bytes are used to measure the capacity of hard disks, 80 GB or 80 GB. Bits and bytes use prefixes to indicate large values. Note that the measurement is in base 2. A common mistake is to think that the binary kilo prefix refers to a factor of 1,000. Actually, the closest to 1,000 is binary is 2 raised to 10, which is 10, 24, and not 1,000. Knowing that, we can evaluate then that a kilobit is 1024 bits and a kilobyte is 1024 bytes. Note that the prefix is lowercase for the decimal kilo and uppercase for the binary version. The table shows the prefixes with the corresponding abbreviation and capacity value. Hard drive manufacturers provide approximate non-formatted capacities. Hence, an 80 GB HD will not show 80 GB after formatting. Sometime in the 90s, some manufacturers used myobytes to mean million or 106 bytes. In 2005, they introduced a new standard for binary prefixes that includes KB for 210, MIB for 210, GB for 210, etc. These prefixes have been well adopted so far. Digital electronics. How are bits stored and transferred from one point to another? Storage is either via electronic switches or electronic charges. Electronic switches are either on or off, while charging devices are either charge or discharge. One of the two states is identified as 0 while the other is 1. Since most computers are electronic devices, bits take the form of electrical pulses traveling over the circuits. All circuits, chips, and mechanical components forming a computer are designed to work with bits. This is the basic part of a computer. We have the input devices going to the processor or the CPU together with the memory. As a whole, it is the computer, and then proceeding to the output devices. Digital electronics. Input devices are machines that generate input for the computer, such as keyboard and mouse. Processor or CPU, central processing unit, is the central electronic chip that controls the processes in the computer. It determines the processing power of the computer. Memory is the part of the computer that stores applications, documents, and systems operating information. Output devices are machines that display information from the computer, such as monitor, speaker, and printer. What is a software? Software is defined as a program or set of instructions that tells the computer what to do. Computer programmers write these instructions using various programming languages such as C++ and Java to tell the computer hardware to perform specific tasks. Examples of software are Apple OS for Macintosh or Windows 98, 10, 7 for a PC, the games we play for the tools we use to compose letters or do math problems. Computer program or program is an organized list of instructions that when executed causes the program to behave in a predetermined manner. Without programs, computers are useless. Support module, an auxiliary set of instructions used in conjunction with the main software program. Example, dynamic linked libraries. Next is the data module, contains data, not supplied by the user, necessary for the execution of certain tasks. Data modules have a variety of extensions like .HLP and .TEXT. Support modules often have the .DLL extensions. Program files have .exe extensions. The examples presented in the slide are EULA.txt, which is a data module. The npwmsdrm.dll, which is a support module, and setup_wm.exe, which is the program file. Sometimes the term software is used too loosely and could cause confusion. Before, the term software is always associated to all non-hardware components of a computer. However, modern definitions make it clear that all documents, spreadsheets, and even downloaded materials from the internet are now classified as data, which means that not all non-hardware components of a computer are classified as software. In computer science, code generation is a compilation stage that outputs machine code in the target language. Code can appear in a variety of forms. The code that a programmer writes is called source code. After it has been compiled, it is called object code. Code that is ready to run is called executable code or machine code. Initially, a programmer writes a program in a particular programming language. This form of program is called the source program, or more generically, source code, to execute the program. However, the programmer must translate it into machine language, the language that the computer understands. The first step of this translation process is usually performed by a utility called a compiler. The compiler translates the source code into a form called object code. Sometimes the object code is the same as machine code, or sometimes it needs to be translated into machine language by a utility called an assembler. Application software versus system software. Software is basically categorized into two: application software and system software. Application software are computer programs used to accomplish specific or specialized tasks for computer users, such as creating and editing documents, word processing, making graphic representation, or listening to MP3 or MP4 music. Example of application software are word processors, spreadsheets, accounting programs, graphics software, and games. System software are programs that control the basic operations of a computer system, such as saving files in a storage device like a hard disk or floppy disk, printing files, accepting input from a keyboard or mouse, execute programs, etc. Examples of a system software include operating systems, communication control programs, interpreters, compilers, debuggers, text editors, linkers, and loaders. The figure illustrates how system software supports application software. The computer user instructs the application program to print a document. The application software, or example, the Microsoft Word, make a request to the system software to print the document. The system software, or the OS, and then the device drivers controls the printer as the document is printed. Then it will be output into the hardware or the computer printer. Next, we have the software development life cycle. Software Development Life Cycle, or SDLC, is a methodology that is typically used to develop, maintain, and replace information systems for improving the quality of the software design and development process. SDLC follows completion of logical sequence of stages or phases. The output of one stage becomes input for the next stage. In order to create systems with good design, we must take into consideration that it must involve several phases. You can develop software in one big attempt. Furthermore, it would be very favorable for companies to have certain set of standardized steps that would serve as a guide in systems development. SDLC involves 5 phases. Each phase plays an important role in creating a good system. The said phases are planning, analysis, design, implementation, and maintenance. Note that implementing SDLC may involve several approaches. It is possible that other books may have a more detailed explanation to the approach of SDLC. Our intention is just to have a basic, not comprehensive understanding of SDLC. The first phase is the planning phase. Planning is the initial stage in the SDLC that has to be performed. This phase includes information about the requirements for the proposed software. Also, this phase is known as the feasibility study phase. For larger companies that deal with complicated software, it is vital that these requirements are properly identified so that the development of the software may not be delayed or strayed from the original objective. The purpose of the planning phase is to conduct a high-level investigation of the business or project and come up with a recommendation for the solution. The analysis phase requires the analyst to thoroughly study the current procedures or software used to execute tasks in an organization. The main goal in this phase is to identify the requirements for new software or simply change several aspects in the current working software. The purpose of this phase is to conduct a detailed analysis of the project or current business needs and identify what options are available to achieve the needs. The activities performed by the analysts during this phase are study the current software, determine software requirements, write requirements report. Design phase. During the design phase, the developer of the software translates the results of the previous phase into actual design or specification of the software. Development of the software involves covering the input and output screens to reports, databases, and computer process. The purpose of this phase is to identify and document a solution that will be constructed according to technical and procedural specifications. Design document will be created that should be included but not limited to technical, environmental, data, program, procedural, and testing specifications. The activities performed in this phase are: identify potential solutions. Next is evaluate solutions and select the best. Next, select hardware and software. Develop application specifications. And lastly, obtain approval to implement the new software. After the design phase, we must put the proposed software into the test. During this phase, implementing the software will include several steps. First is coding, creation of the actual program. Next is testing. Both programmer and analyst submit the software to various quality testing to discover if there are any bugs within the software. Lastly is installation. After coding and testing is done, the actual software must be installed and slowly or completely replaces the old software. The purpose of the implementation phase is to release a fully tested and operational product to an end user or customer. The product should meet all the requirements. With every phase being completed, perhaps the maintenance phase would be the most prevalent phase of all. There are some bugs in the software which can't be properly identified without putting the software into actual use. The maintenance phase is used to make necessary patches to remove found errors. This is where the software is systematically repaired and improved based on the errors or possible new requirements found. These are some of the examples for the software development life cycle. The waterfall SDLC suggests that prior to the next phase, the current phase should be finished first, but applying this strategy in the real world would be unfeasible since it would be impossible to modularize system development. Currently, waterfall SDLC is not recommended to use in creating or in developing a software. Modified waterfall. This version of the SDLC is more flexible compared to the traditional SDLC model. Since the nature of developing software is unpredictable, using this model will allow the developer to adjust to certain situations, such as unforeseen requirements or additional features that are highly intended in the software. Lastly, we have the iterative SDLC, allows phases to repeat if necessary. So these are just some of the examples that you could use in software development. There are many more examples that we could use in the SDLC phases. That would be all for our discussion. Thank you for listening.